Yes, sir. Let's start.
Yes.
Yeah, let's start, sir.
Okay. So hello guys. Today we will take a session on strength of material, and in this I am going to cover principal stresses topic. So very quickly we will go through the syllabus, strength of material for the aerospace part. So here we have the first topic is stress and strain, and then we have three-dimensional transformations. Then we have Mohr circle, principal stresses, right? This particular topic I am going to discuss today. In short, I will discuss all the points regarding this particular topic. And then we have three-dimensional Hooke's law, plane stress and plane strain. Then we have failure theories. Failure theories, of course, we have five theories of failure, but they have mentioned maximum stress, Tresca's, Bol-Mises, and strain energy theories of failure. Then we have Castiglione's principle, statically determinate indeterminate trusses and beams. And then we have elastic flexural buckling of columns. So these are all the topics that we need to discuss. Just a minute.
Yes, Rahul, sir. Anything?
Yes, yes. So I'm joining through mobile also for chat.
Yeah, sure. Please.
So I need to see YouTube uh, chat section, sir, or here
Not
only.
required, sir. Here you can see.
So these are the topics that we need to cover. Apart from that, we have thin structure also that will be covered by Dinesh sir. So in this one, important topic will be stress and strain. Uh, the first two lines are very important. Every year we have one question from this particular lines, and then we have theories of failure. Again, one question will be there. Then we have columns. Again, from the column, what we are observing that from the past 5 years, continuously they are asking 2 marks problem. So that also very important. Coming to mechanical, so here we have to discuss again a very similar topic only what we have seen for aerospace. Here they have included in mechanics of material, that is stress and strain, elastic constant, again Poisson ratio, Mohr circle for plane stress and plane strain, and then we have thin cylinder. Thin cylinder is there for aerospace also. Shear force and bending moment diagram, of course, it will be there. Bending and shear stresses, the concept of shear center, deflection of beam. This is a new topic which introduced in 2021, and deflection of beam, torsion of circular shaft, Euler's theories of column. Then we have energy method, thermal stresses, strain gauge, and Rosette's testing of material with the universal testing machine. Then we have testing of hardness and impact strength. Right. So these are all the topic we have to discuss for mechanical. Right. Especially testing of material with the UTM is not there in the aerospace, but we will try to see through stress versus strain diagram, the graph which we plot. Okay. Coming back to the reference book that we need to follow for strength of material, that is Mechanics of Material by James M. Gary. Then we have to follow BC Pneumonia. Then Mechanics of Material by R.C. Hibler. Right. So this is very important. The first one is what basically IT professor they are picking question from this book, only changing the data as well as some few things to let's say we have one page solution in Garage, so they will try to make question that can be solved within half page or within 3 minutes. But very similar questions will be given in the Gary only. That is solved example and unsolved example. Then this is also a very good book. That is the BC Pulmia for deflections and some other topic. I will mention specifically in the class for what you need to follow BC Pulmia. Solved example you have to solve thoroughly for regarding this book because directly questions will be there in gate exam. Whatever the tough question you are observing, that will be taken from this book. Then Mechanics of Material by Hebler. Again, both are same thing. Any one of this you can follow. So this is regarding books. And then we have okay, one more book is there. That is Aircraft Structure by Maxon. Aircraft Structure by Maxon. The first two chapter you can basically follow from this particular book. So these are the topics that we need to discuss. That is, these are the sequences in which we will cover our syllabus of strength of material. So before starting discussion on principal stresses, we will go through very quickly what is the need of principal stresses and why do we have to find the stresses specifically on a particular inclined planes, right? Okay, no doubt. Very first of all, note down the stress. So what do you mean by this stress? Anyone know that? So any one of you can please tell me the definition of stress. Need not to be exactly, but whatever you know, you can tell. Basically, it is describing the intensity of internal force, right? It describes the intensity of internal force, internal force acting on a specific plane, acting on a specific plane or area, acting on a specific plane area, passing through a point, passing through a point. So very important keyword is internal force. Because of internal force, basically stress will be developed. Without that, we cannot say anything about the stress. Uh, this will be the internal force, internal resistive force. So of course, you know something about this stress, and you also know how many indices will be required. We require two indices to basically specify stress, right? Sigma, I, and J, where I will denote the plane and J will denote the basically what? Tell me, guys. If I want to specify stress, then by the cubical element, let's say this is X, this is Y, this is Z. Then what is the I will denote, and what is the J will denote? So if I write here sigma X X, if I write here, let's say tau XY, or we can write sigma XY. Then first will denote the plane, and second will be denoting what directions. First will denote the plane in which it is acting, plane or a phase in which particular phase or a plane the stress will be acting, and the second will denote the directions, in which direction it is acting, right? So generally phase will be determined the axis which is passing perpendicular to the plane, right? Axis which is passing perpendicular to the plane. So here this is nothing but yz plane. Whatever the I am doing hatching here, this is nothing but your yz plane. What is the axis passing perpendicular to the yz plane? X. That will become your phase, x phase, x direction. That is sigma xx, right? So you know this basic thing. Now coming back to suppose any material you take and you just apply any kind of loading, whether it is normal stress or twisting movement you apply, or any kind of bending movement. Because of that, if you draw basically any element you take on the top surface of a component, then you will see that the state of stress, 2D state of stress, if you want to draw for a particular point A, then how can you make? There will be sigma xx, there will be sigma xx, there will be sigma yy, there will be tau xy, for example. Because of twisting moment, torsional shear stress will also be developed, right? So this is the state of stress, that is the 2D state of stress for the point A, which is situated on the top surface of, on the top fiber of a component. Of course, there will be dimensions. D is the diameter of a component. Again, let's say it is a basically brittle material, for example. Let's say this is the brittle material, right? And we know that brittle materials are very, very weak in tension. They might be strong in shear, but they are very, very weak in tension. Now, when you focus on plane, this plane and this plane, they are subjected to both normal stress and shear stress, and they are not the maximum normal stress. For a brittle material, we want to see what kind of maximum stress, what is the value of the maximum stress that causing the failure, that causing the brittle failure, right? It might be acting, it might not be acting on this AB plane. Let's say I'm calling this to be CD plane, this to be EF plane. So the maximum normal stress which causing the failure, maximum normal stress which causing the failure of this brittle material, we want to find, and exactly where this maximum normal stress is acting, that we need to find. For that, we need to take a plane which is there at an angle theta, right? So we want to see where exactly on which particular plane which is being inclined at an angle theta, where the maximum normal stress is acting. Once we know that this is the plane where the maximum normal stress is acting at this particular angle from this particular EF plane, then we got to know that along this the material might be failing on the plane EG. That may be the failure plane, and which is causing the what value of the maximum normal stress causing the failure, that also we can know. That particular value also we can get to know from this particular concept of what, the maximum value of the or we can say stress acting on an inclined plane, right? So here, very quickly note down determination of these stresses on an inclined plane. This is coming under the topic of principal stresses. Now it's very clear, all of you, why we are determining the stresses on an inclined plane. See, whatever the stresses we know on this CD, EF, and FD plane, that is already known by the strength of material formula, right? What is sigma xx? F divided by area. What is tau xy? That also we know 16T divided by pi dq. But on an inclined plane, if we want to determine, that is not known by general strength of material formula. For that, we need to determine what is the value of the sigma n theta that may be the having certain equations. That equation we need to determine, right? So here, determination of the stresses on an inclined plane. Any plane you can take. For example, a component, let's say we have certain element, 2D element, where we have x, sigma xx, we have sigma y. Here also we have sigma x, sigma y. So these are the stresses that may be acting on this particular element, right? These are the stresses which are acting on a particular element. Now again, you try understanding what I'm saying. Here, if you want to determine, see, what is my x and y? This is my x and y coordinates. You can see very clearly what is the x-axis. This is the x-axis. This is the y-axis, right? Now I need to determine value of the normal stress at an angle theta, at an angle theta, this on this particular plane. Now what is our transformation is there? Now I need to determine, now I'm transforming my equations, my axis from x and y to s and t. Are you getting my point? Means suppose, what I want to say, this is the plane. Now if this particular plane is inclined at an angle theta, what is the axis passing perpendicular to this particular plane? This particular axis will also be inclined at an angle theta. Agree with me? In the counterclockwise directions. Check it out. If I consider a plane, let's say CD, which is being inclined at an angle theta from this CE plane in the counterclockwise directions, the axis passing perpendicular to this plane will also be inclined at an angle theta or not? From the trigonometric, yes or no, guys? This will be 90 minus theta. Again, this will be 90 minus theta. So automatically this will be theta. Yes or no? Correct. Now, once you know, all of you are understanding or not, this is very important. Once you understand initial 5 minutes, we can solve the problem very easily. Now, this particular x-axis, which was earlier x-axis was like this, and y-axis was like this. Now, tell me, x-axis will also be inclined at an angle theta or not? And that will become s, or you can call x dash, whatever it may be. And now if that will be inclined at an angle theta, what about the y? Y will also be inclined at an angle theta, and that will become what? Y dash, or let me call t. Yes or no? So we are transforming our basically axis from what? We are transforming our axis from xy to st. That is the new coordinates. That's why sometime whatever the equation we gonna derive, these two equations, we say these are the transformation equations. These are the transformation equations. See, x, y, s, t. This is inclined at an angle theta. This will be 90 minus theta. This will be theta. Is that clear now? X will be transformed to s and y will be transformed to t. When x will be basically what? When the particular plane is inclined, or axis passing perpendicular to that plane inclined at an angle theta, right? Then what will be happening? X will be transformed to s, y will be transformed to t. Yes or no? See, both are perpendicular. Why there is a confusion? I don't know. Why both are perpendicular, right? Now, what is the transformation equation? If you want to transform from xy to st, this is the matrix, no doubt. And from that, sigma s, what is the sigma s? C square sigma xx plus s square sigma yy plus 2cs sigma xy. Now, what is sigma s? What is c? C we know cos theta. What is s? S we know sin theta. That is abbreviation for C and S. Then, my dear friend, we can write here sigma xx cos square theta sigma yy sin square theta plus 2 sin theta cos theta, that will be sin 2 theta into sigma xy. Remember sigma xy, we also sometimes write tau xy. That is a shear stress. That is a shear stress, right? So that is a sigma t, sigma s, that is being active on a plane which is being inclined at an angle theta or axis passing perpendicular to that plane will also be inclined at an angle theta from the horizontal axis. Either you say plane, see, understand what I'm saying. These are the very, very important. No need to get panic. What I'm saying, a plane is inclined at an angle theta from the vertical in the counterclockwise directions, or an axis passing perpendicular to that plane, and that axis will be inclined at an angle theta from the horizontal in the same anti-clockwise sense. Both are having same meaning, right? Either you say, either you can define a plane or you can define an axis passing perpendicular to that plane. Okay, so once you know this particular fundamental equations, right, when you simplify, you will get this equation, no doubt. That is a school mathematics. What is the formula for, basically we can write here 2 cos square theta minus 1, that is cos 2 theta, 1 minus 2 sin square theta, that will be cos 2 theta. When you use these two equation, you will arrive this first equation, equation number 1, from equation number 0. Make a note of it. This is the normal stress on a plane inclined at an angle theta, anti-clockwise. What about the tangential stress, sigma st or tau st? That is minus of sigma x minus sigma y by 2 sin 2 theta plus tau x by cos 2 theta. No problem. So this was my plane, which is being inclined at an angle theta. This is my sigma s, and this will be, my dear friend. See, what is our x? X is this one. What is our y? This is my y. This will be my s, and this will be my t. This will be my t. When sigma s theta will be coming out to be positive, for example, that means according to our standard sign convention, sigma s will be acting away from that plane. What about tau s t? When tau s t coming out to be positive, then it will be acting in the same direction as in the t directions, like this. Whether it is clear, the direction of sigma s and tau s t, you can also write this to be sigma s s. Whether direction is clear, because all the fundamental things are hidden in these two equations only. This you can write equation number 2. Tell me guys whether it is clear. We will solve the problem. Through that particular problem we will come to know, right, how to solve, how to proceed, right? But first of all, tell me whether you are understanding or not these two equations. Again, how we are getting the equation number 2? Very simple. Equation number 2 you are getting from this one. What will be there? Sigma st, that we can write minus of cs sigma xx plus cs sigma yy plus c square minus s square into sigma xy, or you can also write like this. Again, simplify, you will get what? This equation number 2, because cos square theta minus sin square theta will be cos 2 theta, will be cos 2 theta. Understanding or not, all of you? Yes, Surendra, Vijay, all of your understanding? Right. Once we solve the problem, then the things will be more clear, as it might be looking for some of you difficult to analyze or visualize. But It is very easy once we solve the numerical. So all of you have noted down. Okay. Again, what is the resultant stress? Once you know that on a particular plane, which is inclined at an angle theta, there will be sigma s, there will be sigma st. The resultant will be obviously somewhere here. The resultant might be acting. The resultant will be sigma s square plus sigma t square. That you know from engineering mechanics. There we define one more thing, that is angle of obliquity. Angle of obliquity, that is phi, that is being basically defined here. From the resultant, whatever the resultant will be there, the angle which is made by resultant with the sigma s or this particular s particular axis, this is phi. So when you write tan phi, you can write sigma st divided by sigma s, whereas phi will be tan inverse of sigma st divided by sigma s. No doubt. Angle of obliquity, that is angle which is made by resultant with the s axis, not x, s axis. In some of the textbook you will find x y, it may transform to x dash and y dash. Of course we have derived here for s and t, but some of the textbook they used to write x dash y dash, x y being transformed to this axis. That's why we say transformation equation, because we are transforming from x y. Okay, I'm audible. Hello, hello, I'm audible. Okay, there is a power cut in my area all of a sudden. Yeah, just now power came. Yes, yes, we will resume in 1 minute. Okay, just a just a second. So all of you can see my screen. Hello, hello, hello. I'm audible, and all of you can see my screen. Okay, okay. So what I was talking about, angle of obliquity means the angle made by the resultant with the s axis or x dash axis. Not on the next point, principal stresses and strain. The principal planes are the planes on which only the normal stresses will act. What is the meaning of that? The principal planes are those planes where on which only the normal stresses will be acting with the zero shear stress. The normal stress across the principal plane will be called as principal stress. For example, here sigma xx and tau xy both are acting on this AB plane. This AB plane is not a principal plane, but there will be certain a plane CB plane where only sigma is acting. There is a no shear stress. That particular theta will become principal plane and that particular sigma will become principal stress, sigma p. Of course, how many sigma p will be there? Two, because you have two planes which are perpendicular to each other. Because not only this plane, there will be one more plane where which is inclined at an angle theta, where you have sigma p2. So you have two principal stresses and two principal planes, because obvious planes are what? Perpendicular to each other. Now, what is the formula for determining the principal stress? Note on the first formula. Note on the first formula for determining principal stresses. No need to worry, we will prove each and everything in our regular class. But here, as we don't have that much of time, so we have to discuss problem also. So I am just directly telling you the formulas, right? Where sigma 1 and 2, you will get two values, right? You will get two values, plus and minus. Plus will give you sigma 1. Note down here, important point. The plus sign will give you, put a note. The plus, whatever the plus is there, this plus minus, right? But the plus sign will give you, plus sign gives the algebraically larger principal stress. And the minus sign gives algebraically smaller principal stress, smaller principal stress. Now, my dear friend, yeah, we can call maximum, minimum, major, minor. Now, why there is a confusion? Because we are discussing this note point from many years, but luckily this particular year, in gate examination, gate 2023, in your paper only, they have tested whether you know this meaning or not, whether you know the plus sign will give algebraically larger. Algebraically means mathematically. For example, for example, sigma 1 and 2, you got two values, minus 90 plus 80. Now tell me what is a sigma 1 and what is sigma 2. What is the major or minor, major or maximum principal stress, and what is the minor and minimum principal stress? Tell me guys. According to this definition of defining the principal stress, minus 90 will be what? The plus sign will give you algebraically larger principal stress. Whatever the 80 megapascal will be there, that will become what? Tell me guys. That will become what? Sigma 1. What about sigma 2? That will be minus 90 megapascal. They are defined like that only. They are defined like that only. Mathematically, 80 is greater than minus 90. Mathematically. Oh, sorry. Yeah. Mathematically, this is the larger value. But intuition wise, suppose you are a design engineer and you want to design the beam or column, definitely you will take minus mod 90 will automatically greater than mod 80. There's no doubt about it. So for intuition point of view, for design point of view, you have to take minus 90 megapascal or 90 megapascal for our designing purpose. For our designing purpose. But the principal stresses They are not defined based on the intuition. They have defined based on the mathematically. Plus sign will give you algebraically larger value. Minus sign will give you algebraically smaller principal stresses. That's it. They have tested this one. One of the question of GATE 2023, they have clearly mentioned that minor stresses, they have asked magnitude of the minor principal stress cannot be larger than magnitude of the major principal stress, whether it is a correct statement or incorrect. That they have asked one question in GATE 2023. So magnitude can be larger because you can see magnitude means minus 90. 90 is greater than 80, but mathematically 80 is greater than minus 90. Right? So these are the very, very important points uh, nowadays for MSQ question, MSQ based question, right? No doubt. But how to determine the planes? On which plane? This theta, this is theta p1, this is theta p2. On which, how to determine these two particular value of theta p1 and theta p2? What is the formula? The formula for determining the theta p1 and theta p2 will be this one. Note down. Tan theta 1 or tan 2 theta 1 will be 2 tau xy divided by sigma x minus sigma y. How we are getting? That's a very simple. Simply tau s theta will be equated to what? 0. Whatever the equation we have seen, equation number 2, you just equate to 0. That will give you two value of the plane, because tan inverse when you do, you will get two values of theta. One is theta 1, other is what? Theta 2. And both the planes are what? Perpendicular to each other. Whatever the angle will be there between them, theta 2 minus theta 1, that will be 90 degree, right? Like this one, CA plane and AB plane, they are perpendicular. Likewise, CB and CE, they will also be perpendicular. They will also be perpendicular, right? So I am discussing this minute detailing so that while solving the numerical, it will be very easy for us to go through that. Now let us discuss the problem. Now one more thing is there. Now, why we are determining the principal stress? Because brittle materials are very, very weak in tensor. So we want to see what is the maximum value of the normal stress that causing the failure in the brittle material. Now what is the next thing? Ductile material. Ductile materials are very, very weak in shear. So we want to see exactly on which plane it is failing, and what is the value of the that maximum shear stress, right, on that plane. That we need to determine, and for that, what is the formula we have? See, note down the next thing. Maximum shear stress. The location of maximum shear stress plane. This is the formula we are having. And how we are determining? Whatever the tau is theta formula is there, right? Whatever the equation number 2 formula is there, right? You try to differentiate and equate to 0. Because for maximum and minimum, we have to differentiate and equate to 0, right? So that you will get tan to theta, that is 2 tau xy divided by sigma x minus sigma y. Just wait. Here, this is the formula. No, this is the formula for determining the principal planes, right? For determining the principal plane. These are not the formula for determining the maximum shear stress planes. So, no. This is not the formula. So, this is the formula for principal plane. That is what we have seen earlier also. Alternate way of finding the principal stresses, whatever the matrix will be there, you just try to find how you solve the matrix, whatever the A matrix is there, minus lambda into I, whatever the you find the magnitude of this, that will give you the values of whatever the lambda is there, lambda 1, lambda 2, lambda 3, that will become sigma 1, sigma 2, and sigma 3. This is the alternate way, right? Second way of determining the principal stresses, right? What is the maximum shear stress and the planes of maximum shear stress? This is the formula. And how we are getting this formula? D tau is theta divided by d theta equated to 0. Either you can write tau st or you can write sigma st. Right? Note down, very, very important. On which plane maximum shear stress is acting? And remember, this is the plane over which whatever we are determining, that is in plane. That is not the absolute. For absolute, we have separate formulas. There are two types of maximum shear stress. One is the in plane maximum shear stress. Other is the absolute maximum shear stress. This is the formula for in plane. On this particular plane, suppose this is a plane, and now this is the particular plane over which the maximum shear stress is acting. On this maximum shear stress, there will be normal stress that will be acting. The normal stress will not be zero. Will not be zero. It will be there. And what is the value? Sigma x plus sigma y by 2. Sigma x plus sigma y by 2. Both the planes, this plane as well as this plane, which are perpendicular, they're gonna have sigma n star, sigma n star. Here also we will be getting what? Theta s1, theta s2, and theta s2 will be what? Theta s1 plus 90 degree. Because tan inverse, when you do, you will be getting what? Two values from trigonometric. Note down. I think it's clear, right, to all of you what actually we want to say, right? Now, magnitude I have not discussed. I have not discussed how to determine Tom x. Tom x is very simple. Whatever the theta is equal to theta s1 is there, you put into that formula. Which formula? This one. This particular formula. You put that one. Whatever the values of tau s theta will be there, that will give you Tom x. And remember, Tom x. Remember, shear stresses are complementary in nature. That means whatever the maximum shear stress will be acting on this plane, the same maximum shear stress will be acting on this plane to satisfy couple equilibrium. What is a couple equilibrium? Moment equilibrium. Those are all the things we will discuss separately in our regular session. Understanding? All of you are understanding? Shall we discuss the problem now? Now see the problem which we are talking about, and try to see how to proceed. Okay, note down. Now try to solve this particular problem. What Whatever the problem we are seeing, observing right now, that is being asked in gate 2021 A. For the state of stress shown in the figure, here x and y axis they are given. Now according to our standard sign convention, what is the sigma xx? Minus 80 or plus 80? Minus 80, right? Because our standard sign convention for normal stress is sigma xx when it is acting like this or it is acting like this away from a plane, that is a positive. But it is acting towards, that is going to be negative. What is sigma yy? Plus 20 or minus 20? Observe the standard notation. The standard notation should be away. Away. It is acting towards, minus 20. Now, whatever the formula we have derived, right? This particular formula, whatever the formula, two formulas we have derived, right? That I told you. Equation number one, equation number two. This particular formula we have derived. for this particular state of stress, where tau xy is acting like this, where tau xy is acting like this. That means on this particular phase, this is acting in anti-clockwise directions. On this top phase, it is acting in the clockwise directions, like this. So whenever any state of stress will be given to you, you try to see standard state of stress, whether it is matching or not. Here, what you are observing, it is not in the upward direction, it is in the downward directions. So automatically tau xy will be minus 30 megapascal. Understanding my point? Our standard, what the notations we have, our standard state of stress was something like this, where it is acting like this, it is acting like this, it is acting like this. Then we talked that, we have said that this will be positive, but it is acting in the downwards directions. Automatically all other phases will be adjusted according to this, and that will be negative. Now they are saying what is the orientation of a plane with the maximum shear stress. That means they are asking what maximum shear stress plane locations. What is the formula we have? Tan 2 theta. What is that? Sigma yy minus sigma xx divided by 2 tau xy. Just now we have seen. What is sigma yy? Minus 20. What is sigma xx? Minus minus will become plus 2 into minus 30. So what you are getting? 60 by minus 60, that is minus 1. So tan 2 theta you are getting minus 1. So now from here what you are getting? 2 theta s1. Can I say 45 degree minus 45 degree? Because tan minus 45 minus 1. What about the other values? Once you got theta s1, that is minus 22.5. Automatically, what about theta s2? Theta s2 will be theta s1 plus 90 degree. So that will be 67.5 degree. That is theta s2. Theta s2, right? Understanding my point, all of you. So now I want to show one plane, one maximum shear stress plane which are inclined at an angle theta minus 22.5 degree. From the vertical, from the vertical plane. This is our derivation, right? From the vertical plane, this will be our positive things, right? Now, whatever the thing is there, that is a negative. That is a negative means what? This plane is inclined at an angle what? Clockwise. Getting my point? Minus 22.5 degree. Yes or no, guys? And what is the other plane? Other plane will be inclined at an angle what? Other plane will be inclined at an angle what? Other plane will be inclined at an angle what? This is the plane AB, which is being inclined at an angle what? Minus 22.5. Other plane will be inclined at an angle what? 67.5 degree. Getting my point? Tell me, guys. AC will be there, which are inclined at an angle what? 67.5 degree. Yes or no? Tell me, guys. Any confusion in this one? Positive sign means positive is what? Anti-clockwise direction from the vertical. Negative is what? Clockwise direction from the vertical. Vertical can be anything, need not to be this vertical. It can be any vertical. This will be the plane. Now they are asking what is the orientation of the plane with the maximum shear stress with respect to x-axis. Now tell me this axis passing through this AB plane will be inclined to what? Minus 22.5 degree, right? Actually, I should not write minus because clockwise will automatically show you the it will be self understood that is acting in the clockwise directions, right? So what about this 67.5 degree, and what about this 22.5 degree? Now tell me, this is AC is also maximum shear stress plane, AB also maximum shear stress plane with respect to x-axis. Now tell me the angle. One angle is what? Minus 22.5 degree. See that. Other is what? 67.5 degree plus. In the option 67.5 degree, it is not given. Minus 22.5 is given. It is correct. Any doubt, you can ask me. The location of a plane is how to specify the oriented plane or asked plane, whether it is clear or not. Tell me, guys. Right? From the vertical, I told you in the derivation, from the vertical. Vertical need not to be this vertical. It can be any vertical, this vertical, any vertical. It's up to you. You have a lot of flexibility. Right? Now, uh, try to solve this particular question. Okay. Try to solve this question and tell me the answer. See, which of the following will determine will be the correct which of the following objects will be inclined at an angle 45-degree subjected to the given stresses are in static equilibrium. Remember when we do the derivations, when we do the derivations, whatever the formula you have seen, sigma and theta, what we call sigma s, tau s t, what we call sigma st. This two equation has been derived by equating summation of forces in x direction to be zero, summation of forces in the y direction to be zero, and that is nothing but what? Static equilibrium equations. Static equilibrium equations. Then whatever the figure will satisfy, these two equation will be the answer. Will be the answer. Very first of all, you try to find sigma and theta. What is the theta? Theta is what? Plus 45-degree. You try to find on a plane theta, which is being inclined at an angle theta, 45-degree. For determining the 45-degree plane, what is the formula we have? Sigma xx plus sigma yy by 2 plus sigma x minus sigma y by 2 cos 2 theta plus tau xy sine 2 theta. Now tell me, what is sigma x? What is sigma x in this particular problem? What is the sigma x which is being acting? Tell me guys, what is the sigma x in all the figure? Plus 30 megapascal. What is sigma y? Plus 40 megapascal. What any tau xy is acting? Any tau xy in all the figure? 0. 0. Put 0 it is. 30 plus 40 by 2. 30 minus 40 by 2 cos 90. Cos 90 will be what? Again 0. So 35 megapascal. Plus means what? It will go away. It will go away. Right? That is given in all the figure. 35 megapascal. So this 2 is wrong. 35 root 2 is they have given. That is wrong. 35 megapascal. What about tau s theta? What about tau s theta? What about tau s theta? Tau s theta will be what? Minus sigma x minus sigma y by 2 sine 2 theta plus tau xy cos 2 theta. Minus sigma x is what? 30 minus 40 by 2 sine 90 plus 0 tau xy. So what you will be getting, my different? You will be getting 5 megapascal. 5 megapascal tau s theta is acting plus or minus plus. If it is acting plus, if it is acting plus, then tell me if we have inclined, if we have just rotated, if we have just rotated a plane, now this will become S, this will become T. Then I told you whenever we are getting plus, whenever we are getting plus 5 megapascal, it has to be acting like this in the same direction of T. And 35 megapascal will be like this away from the plane. Which option will be saying that one? B option. Understanding all of you? Once you know fundamental, you can solve all the problem within fraction of second. Yes or no? Is that clear, all of you? Now we will quickly solve some other problem here. Again, typical problem, not a very tough one, but this particular problem is based on the equilibrium concept. I told you, whatever the equation we have derived, that is based on force equilibrium conditions, static equilibrium conditions. Now, when you look at in this figure, it's not a very regular figure. What we are observing, a parallelogram shaped, whatever the parallelogram shaped plate is given, that is being subjected to sigma 2 and sigma 1. But sigma 2 is not a very straight away. It is being there at an angle theta, maybe. So to avoid that confusion, we will take some part of that element. Let me take A, B, C. If A, B, C, whatever the A, B, C is there, if A, B, C will be under a static equilibrium. If A, B, C, let's say here sigma 2 is acting, here sigma 1 is acting. If A, B, C will be under a static equilibrium, then whole parallelogram plates will be under a static equilibrium condition. Yes or no? Whether you know this rule or not, in the strength of material, if any part of the member under static equilibrium, the whole part will be under static equilibrium conditions. Understanding, all of you? All of you are understanding or not? Now, this is, they have given this particular, they have given B. This is the B dimension, they have given B. And this is the angle theta. Then what about this? This will be B sine theta. This will be B cos theta. Getting my point? Now, my dear friend, you do summation of forces in the y direction to be 0. You just do summation of forces. You just do summation of forces in the y direction. What is the y direction? This is the y direction. This will be the x direction. You just do summation of forces in the y direction to be 0. What you will be getting? What you will be getting? Tell me, guys. This is sigma 2. What about the horizontal and vertical component? What about the horizontal and vertical component? This is theta. This will be theta. This will be 90 minus theta. So this will be sigma 2. This will be sigma 2 cos theta. This will be sigma 2 sin theta. Then now we need to determine the forces. Now see, if you do the forces, so sigma 2 cos theta will be acting like this. Now to balance that, what will be there? Tell me, guys, what will be there? How to balance that? Sigma 2 is a stress. If you multiply with a B, that will be sigma 2 into B. Again, you multiply this with the B. What you will be getting? Sigma 2 cos theta into B. That is a force. Yes or no? Perpendicular to this will be width. Width I am taking as 1. Understanding or not? Width I am taking of the plate. Width of the plate is taken as 1 unit. 1 unit. So sigma 2 into B. That will become what? Sigma 2 into B into cos theta. Into B cos theta. Now do the forces summation in the y direction to be 0. So what about this force? This force will become what? Sigma 1 into B into cos theta. That is a force. Sigma 1 into B into cos theta. That is equal to this particular force. Sigma 2 into B into cos theta. So when you do, you will be getting what? Sigma 1 equal to sigma 2. D will be correct. Of course, automatically to balance that summation of forces in the horizontal x direction to be 0, automatically here the stress would be sigma 2 into B into sin theta. That is a force. Understanding why I am multiplying sigma 2 into B into 1. That sigma is a what? Stress. Multiply with the area, you will get the force. Sigma 1 is a stress. Multiply with the area, B cos theta into width. Whatever the width will be there, width I am taking as basically what? 1 unit. Whatever the width is there, I'm taking it as what? Taking it as 1 unit. Sigma 1 into B into cos theta into 1. That is a complete force. Is that clear, all of you? Tell me, guys, clear or not? Right? So this is a very typical example where they have tested whether you know from where we have derived our equation number 1 and equation number 2. Now we will try to solve this particular question which they have asked in GATE 2022 mechanical. A linear elastic structure, they have shown in the figure. They are saying it is under plane stress condition. Now I will discuss in our regular class what is the meaning of plane stress. In the plane stress, the third stresses which are acting on the third phase or in the third plane will be 0. Now these two are basically combined sets of loading number 1, loading number 2. The resultant stress after superimposing these two, when we just if these two sets, whether loading number one and loading number two, are applied simultaneously, the net normal component of sigma xx will be what? Very first of all, tell me in the loading number one, can we say sigma xx will be sigma only? By looking at the figure very clearly, for the loading number one, sigma xx will be sigma or not? For loading number one, sigma xx, sigma xx will be sigma or not? Tell me, guys. Very clearly, a very common sense, a very clear by the definition, sigma xx will be sigma. There is a no doubt. That is a uniaxial state of stress. Uniaxial state of stress. Condition they have given. Loading number two, that is also uniaxial, but on some different orientations. Whatever the orientation is there, they have defined this on x1 and y1. I need to find on x and y. I need to find on x and y. Not tell me I need to find sigma xx. That means I need to find one plane. Understand what I'm saying? This is a shortcut. There is a long cut also, but there is no use of that in examinations. This is the plane. Understand? This is the plane. What I'm saying? This is the plane perpendicular to which? Perpendicular to this particular AB plane. What is the axis passing? X or not? Perpendicular to which axis which is passing is X or not? Yes, it is X. Now tell me this particular plane is inclined at an angle what? At an angle 45 degree from this vertical. Yes or no? From this vertical, this particular plane is inclined at an angle what? 45 degree. In which sense? Clockwise sense. What I need to find? Sigma xx on a plane at an angle minus 45 degree. You simply transform from x1 y1 to x and y. You simply transform from x and y, x1 y1 to xy. Then what you have to use the formula? Sigma xx 1 plus sigma y1 divided by 2 plus sigma xx 1 sigma y1 divided by 2 cos 2 theta plus tau x1 y1 sin 2 theta. There is a no tau x1 y1, right? That is 0. Nothing is there. What is sigma y1? They have given sigma. What is sigma x1? That is 0. Now you determine sigma xx. 0 plus sigma by 2 plus cos 90, that is cos 90. This cos 90 will be what? 0. Tau xy is 0. Nothing is there. So what we are getting? Sigma xx. Sigma by 2. When you combine these two, the net sigma xx will be what? Because of the loading number 1 sigma, because of the loading number 2 sigma by 2, the net will be what? 3 sigma by 2. 3 sigma by 2 is correct. Again, there is a long cut also. Unnecessarily, if you want to confuse yourself in examination, then you can confuse. But that will take time. How? Some of you might be telling to me, sir, whatever the equation we have discussed, that is being there to transform xy to x1 and y1. Whatever you are telling me, you are transforming from directly x1 y1 to xy. This is a very easy way. Now if you do this way, then you need additional equation, means two equation and then two unknowns, then you can get the answer with the help of that, right? What I want to say, all of you have noted down. We got the answer happily, but I'm telling you the way you will try to do in examinations. All of it done, noted down. Tell me, guys. Now what you will do, in fact everyone will do, those who are learning for the first time in examination, suppose you are very good students of strength of material, definitely you will do something like this. You know, this is what we have: x1 y1, this is x, this is y. This is the normal notations. Now here this particular things they have said that it is 45 degree. Now Now understand. We want to find sigma x. We want to find sigma x. We know sigma xx. What we know? We know sigma y. We know sigma y1, right? Now tell me sigma y1. We know that is sigma, right? That is being given sigma. Now tell me what at what particular what is the angle of this plane on which sigma is acting? What is the angle? What is the angle? Can I say from the vertical 135 degree in the counterclockwise directions? Check it out. Not getting how 135 we are getting? See here, when you see clearly, this is 45 degree, and this axis which is being passing perpendicular, this will be inclined from the x-axis 135 degree. Check it out. This is 45 and this is 90, 45 degree. And from the vertical will also be what? From the vertical also, this particular plane, this is what? 45, this is 90. So total will be what? 135. 135 means theta is equal to 135 degree. You have to find sigma x plus sigma y by 2 plus sigma x plus, sorry, sigma x minus sigma y by 2 cos 2 theta plus tau xy sin 2 theta. Again, this is known to you. Sigma x1, that is 0. Sigma x, and what is the value of theta? Theta is what? Plus 45 degree. Sigma x minus sigma y by 2 cos 2 theta plus tau xy sin 2 theta. Understanding my point? You don't know tau xy, you don't know sigma x, you don't know sigma y. From this is the equation number 1. This will be equation number 2. Tell me how the values you are getting. Sigma is equal to what? Sigma x plus sigma y by 2 cos 270. What is the cos 270? Cos 270 0, right? And what about sine 270? Sine 270 will be what? Sine 270 will be minus 1. So this is nothing but minus tau xy. This will become minus. This is the equation number 1. Again, we have here 0, that is sigma x plus sigma y by 2. Sine 90 will be 1 plus tau xy. So this is your equation number 2. You just add equation 1 and 2. What you will be getting? You will be getting sigma x plus sigma y, that is 0. That is what you have equation number 3. Again, tau x1 y1. Tau x1 y1. There is a no tau x1 y1 here. Nothing is there. At an angle what? Theta is equal to 45 degree. So minus sigma x minus sigma y by 2 sine 2 theta plus tau xy cos 2 theta. This will be 0 because cos 90 will be 0. So here again this is also 0. 0 will be what? Sigma x minus sigma y, that is 0. So sigma x will be sigma y. From this sigma x is sigma y, so sigma x will be 0. Just wait. No, when you just add these two together, when you just add these two things together, you will not get sigma x minus sigma y, that is 0. But here you will get p, because when you add these two, 0 plus sigma, that is sigma only, right? That is sigma. That is sigma. Once you get here, you will be getting sigma x, that is sigma y, that is sigma by 2. How lengthy is there? You can check yourself. When you follow our conventional method, you will get sigma x, once again sigma by 2, what we got earlier by our one line equation. Now tell me whether is it easy to transform x1 y1 to xy or xy to x1 y1? Tell me guys. You got the answer sigma x, sigma by 2 here also. You got the answer here also, but in a 3 step. Here 1 step. What we have done? We have done nothing. Whatever this inclination is there, we have treated just like x and y only. And we have founded on this plane, which is inclined at an angle what? Theta is equal to 45 degree. Getting my point? As if we have rotated like this. Clear or not, guys? I'm not confusing you by telling you so many methods. I'm just telling you how you can save the time in examinations. Yes or no? If they would have been asking you tau xy, what is the tau xy value, then you might have done these things, and after that, once you got sigma x and sigma y, you might have found it out this particular equation number 2. From equation number 2, what is the tau xy? Tau xy, sigma x and sigma y both are equal. That is sigma by 2, sigma by 2. That is also equal to sigma by 2. Tau xy will also be equal to sigma by 2. Getting my point? Yes or no, guys? Yes. Not getting reply means confused. Remaining guys, whether you understood or not, right? So these are the ways. I'm not telling you, or I'm not basically telling you for the sake of demo session, right? We will solve the similar, a very tough problem from the textbook within fraction of second, just by the with the help of concept what we learnt, right? A very simple fundamental rules are there that we need to stick with that, and simply when you stick to the fundamental, every problem you can solve. In fact, this particular problem, basically what many topper during that year in mechanical they did wrong. What they have done, they have just ticked the option B. That is sigma. This is sigma, 45 degrees sigma cos 45 sigma by root 2. That's a very blunder kind of thing. No concept, nothing. Right. So okay, guys, we can leave for the day, and that's all about the today's session. Thank you all. Okay, thank you all.
You are currently the only person in this conference.